Hi, in this session we will see about the effect of the gyroscopic couple on an aeroplane, right? So this, this. Suppose you take a four-wheeler or two-wheeler, so there is a contact between the ground and the wheels, so that by steering the wheel, you can have an effective turning either to the left side or right side, or even if you want to go straight. But if in the case of aeroplane, so if it is in air, flying in air, where we want to, suppose we want to take a left turn or right turn, then we need to do something so that this plane will have the desired direction, the turn in the desired direction, right? So here let us take this omega as the angular velocity of the engine radian per second, and the small v as the linear velocity of the aeroplane in meter per second, and the m is equal to mass of the engine and propeller in kg, and k is the radius of gyration in meters, I mass moment of inertia of the engine and propeller in kilogram meter per square. Generally it is calculated from mass into the square of the radius of gyration, and the radius of curvature in meters r, and the angular velocity of the precession is given as omega p, which is equal to v by r radian per second. Therefore, the gyroscopic couple acting on the aeroplane, we have the general formula, that is C equal to I omega p. And in this case, in this slide, you can able to see the front and the top view of this aeroplane. This is front view and this is top view. Suppose if you are observing or viewing from the rear or tail end, okay. Here this one is a nose and this one is the rear or tail end. So we are viewing from a tail end. So the propeller is rotating. This propeller will have either clockwise or counterclockwise direction, and these wings are there. So we will assume this plane is trying to take a left turn, right? So when it takes a left turn, generally this gyroscopic couple would be acting on the left side in this direction, that is counterclockwise, and this active couple will be opposite to this gyroscopic couple. And in problems, after solving the problem, see, finding the solution for the gyroscopic couple, say equal to I omega p, is very simple. The thing is, we have to write down the effect of the gyroscopic couple in case of aeroplane, right? So we have 4 columns here. You have to memorize the turn, propeller rotation, effect, and viewed from. So, so suppose if the plane want to have wants to have a left turn, then and the propeller is rotating in counterclockwise direction or anticlockwise direction, then to have a left turn, we have to dip the nose and raise the tail. Okay, so when you view from the rear or tail end. Similarly, for right turn, for the propeller which rotates in the counterclockwise direction, to raise the nose and dip the tail. This here also we are viewing from rear or tail end, right? Suppose if the propeller is rotating clockwise and you want to have a left and right turn, then just opposite to that of the previous 2 cases. So here dip the nose, here raise the tail, and dip the nose and raise the tail, and similarly raise the nose and dip the tail. So it takes the same thing. Only thing is we have to change the direction of the propeller rotation, right? And the viewing, here the viewing is from front. Suppose if the view is rear or tail, then these 2 cases will change. Okay, so there is a thing you have to remember. At least you remember these 4 columns.